first theory that was proposed, actually before the steady state in the 1920s, is the Big Bang theory. So very simply what you need to do is have a list of all the different points for each theory, so then at least you can compare and contrast. The most likely question that you might have, or the question worth the most mark, would be to compare and contrast the Big Bang and the steady state. So the Big Bang theory is at one single point in time, and that time that we have at the minute, approximately 13.7 billion years, the entire universe was created. So from a very, very small single point, all the energy and matter that we have today currently, so every single galaxy, anything that's in every galaxy that we have today, was created at that one point. Obviously it's evolved over time, so you didn't have a galaxy that was created at the Big Bang. All the energy and matter that went into making the galaxies and making everything that's inside those galaxies, that was created at that time. And then over time it expanded, it came together and it evolved into different things. So you start off at a single point, and the theory goes, space itself is expanding. And back on 7D redshift is where we saw, if you observe all the galaxies or the distant galaxies in the universe, all of them seem to be moving away from one another, which means they're all redshifted, and the further away that they are, the more redshifted they are, which means they're moving away faster. And the best explanation that they had, and we still have today, is if you see an object that is moving away, and then the further the object is, the faster it moves away, the best explanation that we have for that is that the universe itself, space that these objects are in, is expanding. The most obvious example is the balloon. If you draw dots on a balloon and you blow it up, the ones that are further, as the balloon expands, the dots further away will move away faster. You have an example of kind of currents in a dough. So like raisins that you have in a dough, if you were to bake that, so when you start with the dough with the raisins in, you have a small amount of dough, very compact, raisins quite close to one another. You'll have some towards the center and some towards the edges, and as you bake that dough, the outside of the dough will expand, and the raisins that are at the edge of that dough will move away faster than the ones in the middle. So the theory goes, if everything that we look at, every distant galaxy that we observe, is moving away, and the further they are, the faster they're moving, then the best explanation could be that the space itself that it's in is also expanding. All right? So the universe in the Big Bang theory is expanding, and the evidence for that is the redshift of distant galaxies. And all the energy and matter that we have today, everything that we know exists in the current universe, was created at that single point of the Big Bang, which also suggests that the Big Bang theory, the universe had a beginning. So that's one other point that the Big Bang theory states that the other does not, is that we actually have a beginning. There was a start to our universe. Before that, we're not quite sure exactly, but there is a beginning, there is a starting point. No new matter is created. We've said that. Everything that we have was created at the start. There's no more. So even though it's changed and it's evolved, as the universe space itself expands, whatever we had at the start has to fill the space. So there's no new matter being created from 1, 2, 3 expansions of the universe. It's just moving away from itself. So it's the same amount, it's just becoming more and more spread out, which also means that as the universe expands, the density must be getting less. Alright, so as space increases with the same amount of matter moving away, the density of the universe itself will decrease. Okay? And they're your main points for the Big Bang theory itself, which actually came first roughly in the 1920s. Moving on, you have a counter proposal for a theory, which actually came in the late 1940s, called the steady state theory. Alright? And unlike the Big Bang, there is no beginning. So this universe here that is seemingly the smallest part in the increasing size of the universe, this was already there anyway. It didn't come like the Big Bang. It wasn't a small explosion. Nothing was created. The universe itself was already there, but matter was created and put into it. It does agree that the universe is expanding. Okay? They cannot disagree with the evidence of redshift. Everybody is seeing that the distant galaxies are moving away, and the further they are, the faster they're moving. So redshift also has to be explained in the steady state by the universe expanding. So they both agree that the universe is expanding, evidence for which is redshift. However, as the universe in the steady state expands, more and more matter is added every time. So as you see, if the space gets bigger, there's actually more matter being created into that to fill the space. Same again, it gets bigger, more matter is created, gets bigger still, more matter is created. So actually throughout this entire expansion of this universe, the density doesn't change. So even if space gets bigger, the gaps will be filled with new matter and it's constantly replenished. So there's no change in density throughout the entirety of this steady state universe. It has no beginning, which is a direct contradiction to the Big Bang, which said it does, okay? Now this came later. All of these things could be explained, so both theories had merit and both of them could have been accepted. The changing factor for which theory of the universe actually took over the other was what's called CMB, okay? So CMB is cosmic microwave background and it's radiation. It's literally EM, electromagnetic radiation, which is in the microwave part of the EM spectrum. There have been marks in the exam for literally stating what the C or the M or the B stand for in CMB, so cosmic microwave background, radiation. And this is evidence, when this was discovered, and it was discovered by accident, this was evidence that only the Big Bang Theory could explain, all right? And the reason is, if there was a beginning to the universe and all the energy and the matter was created at that single point in time, then the radiation that was created at this point throughout the expansion of the universe, as we know, would have stretched. The wavelength of radiation that was created at the time, over 13.5 billion years, would stretch and its wavelength would get bigger, it would expand. Now, whatever type of radiation you started with, if that expands over time, at this point, 13.5 billion years later, it should be in the microwave section of the EM spectrum, all right? That can't be explained by the steady state because even though it's constantly expanding, new matter is being created. It would never have that chance to be stretched and the wavelength move from one part of the spectrum into the microwave. All right? So the discovery of the cosmic microwave background radiation can only be explained by the Big Bang Theory because over time, the radiation that was left over, so CMB, cosmic background radiation, microwave radiation, is leftover radiation from this point here at the start of the Big Bang. And over time, as the universe expanded, it's stretched and is now in the microwave, which can only be explained if it was created at a single point at the beginning of the universe, not if matter is constantly being recreated. All right? And that's it.